Good morning, everybody. Today I'm going to solve the problem where you have two objects and these two objects are connected by a string. One object is vertically downward and another object is onto an inclined plane. The mass of the object is given, the coefficient of friction between these two surfaces is given, and now you have to find out what is the tension in the spring, what is the acceleration of the system, and what is the velocity or the speed of the system after the mass has moved to a certain distance, in this case 0.3 meter. Okay, so this problem requires an understanding of resolving the forces into the different components using the Newton's second law of motion, as well as using the equation of motion to calculate the velocity. First, the first stage in solving this problem is, let me rewrite this problem first. So this is the problem here, and I'll explain what is the problem here. You have again the two masses. These two masses are connected by a string through a pulley, and this mass rests onto an inclined plane. So we have the given information. Both masses are given. The M2, this is the given information. Given information. M2 is 0.2 kilogram. The M2 of the object is 0.2 kilogram. M1 is 0.3 kilogram. The angle theta is 30 degree. And the nu K is the coefficient of kinetic friction between these two surfaces. And this value is 0.1. And remember, this one has no units. It's a coefficient. The coefficient does not have any unit. This is called the coefficient of kinetic friction. Kinetic friction. And this is a given quantity. Alright? So this is the first information, all the given information. Now let's spend few minutes on to resolving all the forces acting onto the system. Alright, so here, what are the forces acting onto this system, onto this object? The one force is the weight. The weight is the downward. The weight on an object. If you have mass m, what is the weight of an object? The weight of an object is the mass times the gravity. So the weight is mqg. That's the weight of the object. And now this one is supported by a string, so it does have the tension. The tension into the spring is let's say this is T. We have to calculate. We do not know the value at, and we're going to calculate it. And now let's see the system is falling downward, and I do not know the value of A. This is the acceleration of the system. It's falling down, and I'm assuming the value of the acceleration is A. As these two masses are connected by the string, so this one will also have the same tension, and it will have the same acceleration, because these two systems are connected by, these two masses are connected by the same string. So it does have this exactly the same acceleration and the same tension. Now let's see what are the forces acting onto this object. The weight of an object is always the downward, the vertically the downward. Okay, so the weight is, this object is m2g, as I mentioned, the weight is the mass times the gravity. It's always the downward All right. What are the other forces? This system is trying to move this way. There is the friction force. The friction force is always opposite to the motion. So the friction force, I'll just use the different colors probably. So this is the friction force here. The friction force, I'm just writing down Fk, that's the friction force. And there is another force which is upward. This is called the normal force, which is denoted by N. That's the normal force. Okay, the normal force is always perpendicular to the surface, and this one sits onto this inclined plane, and perpendicular to this inclined plane is along this way. That's why it's called the normal force, because it is perpendicular to the inclined plane. So we found out all the forces acting onto the system. Now let's resolve this force into the two components, just to make life easier. Okay, so this force can be resolved into two components. The one component is perpendicular to the surface. So rewriting this one. This is m2z. This angle is theta. This angle is also theta. This component is m2g cosine theta. And this component, we have another component which is parallel to the inclined plane, and this component is m2g sine theta. All right. So I have all the forces. I don't need this force anymore because I have resolved this m2g into the two components. Okay. So now the question is how we solve the problem. The second part is now just writing the equations of motions using the Newton's second law of motion. Let's write down the Newton's second law of motion for this object. We call this object 2. Okay. Equations of motions. The object 1, object 2. When I say object 2, that means the mass m2. So the system is moving the downward. So what is the Newton's second law of motion? This tells you the F net force is equal to the mass times acceleration. All right. So this is the mass times acceleration. This is the net force. What are the net force acting onto this object? There are two forces acting onto this system. The one force is the tension, the other force is the weight. And the system is moving downward. So the net force is now m2 g minus tension. This is equal to the mass times acceleration. This one is the net force, you see, and the tension and the weight are in opposite direction. That's why we have the negative sign here. All right, and I'm going to solve this one for t, and this is m2 because the mass is m2. So this one will be m2g minus m2a. If I just solve for the t. This is my first equation. The same way I'm going to do, I'm going to calculate or write down the equation of motion for the object, second object. Now for the object 2, object 1, again, I'm going to use the Newton's second law of motion, which is equal to the mass times acceleration. All right. So what are the force here? You see the one force is F, the tension, and there are two forces. The one is the m2g sine theta, and the other is the friction force. So the way I can write this equation is now, I have to calculate all the forces along the direction of motion. So this is tension, which is now m2g sine theta minus the friction force times mass times acceleration. This mass is m2. This is m1. m1 times acceleration. Now, how do I calculate the friction force? The friction force for any object is given by, I'm just putting a note here. The friction force, the K simply stands for the kinetic friction. This is equal to the mu times the normal force. Okay? And the mu K and the normal force, you see this normal force, there is no motion along perpendicular to the motion. So that means total force perpendicular to the motion has to be equal and opposite, or the total force has to be 0. That means this normal force must be equal to the m2g cosine theta. So this is equal to m2g cosine theta. Okay, and I'm going to plug in this value, and let's say this is 2 and this is 3. I have to erase this side. Let me erase this side. Now just the algebra now. So I'm plugging, I'm plugging 1 and 3 into equation 2. 1 and 3 into 2. Okay? So this one would be m2g minus m2a minus m1g sine theta, and the fk is minus mu k m2g cosine theta, and this is equal to m1a. I just plug 1 and 3 into equation 2. Now I'm solving for a. So if I solve this value for a, what I would get? Well, I will get m2g minus m1g sine theta. I'm just taking this one to the other side. Okay, I'm just keeping all the other terms the same. I have m2g minus m1g sine theta minus mu k m2g cosine theta, and then I will have m1 plus m2. m1 plus m2. Okay, so now all the parameters, all the you know m1, you know m2, you know g, you know theta, everything we know here. All right. So what I'm going to do, I'm just plugging all the numbers here. Just 1 second. So I'm just plugging all the values here. So if I plug all the values, the number, the value I get for the acceleration, just plug in all the values. The m2 value is already given. What I would get is 0.468 meter per second square. This is the value you'll get. Okay, and this is to the 3 significant, the figures. Just plug in the values of, I'm just writing down the values here. Again, m2, the m2 is 0.2 kilogram, m1 is 0.3 kilogram, mu value is 0.1, theta is 30 degree, and g value is 9.8. So that's the value you will get. Now I'm going to solve for the tension. So we know now acceleration, so I'm plugging this value into this equation now. So if I plug what I will get? The tension T is equal to M2 is 0.2 times 9.8 minus M2 is again 0.2 times 0.468. If I solve, you get the value of tension, which is equal to 1.87 Newton. Okay, that's the value you get now. So we got this one now. The last thing we have to solve is you have to find out the velocity of this object or this object after it has moved 0.3 meters. The velocity of the both objects would be the same. And how do I calculate the velocity? So we have to use the equation of motions. Okay. So I'm going to use the equation of motion. You have to follow my other videos about the equation of motion. We know the acceleration, we know the distance, so I'm going to use this formula. V squared is equal to U squared plus 2AS. The V is the final velocity, U is the initial velocity, 2 is a constant, A is the acceleration, S is the distance traveled. So as the system is starting from the 0, your initial velocity is 0. So what you get here, the velocity is simply equal to now the square root of 2AS. And plug all the values now. We already calculated A, which is 0.468, and the distance is given. This distance is given, which is given 0.3 meter. And now if I solve, plug in all the numbers and solve it, what you will get is 0.530, and the unit of this speed is 0.530 meter per second. So what you learn here is this particular problem requires an understanding of using the Newton's second law of motion. You should be able to know how to resolve forces. You have to know how to use the equation of motion. It's not one problem, it's a combination of 3-4 problems. Okay, and again, if you have any questions, just let me know, write to me, and I'm happy to explain to you. Thank you so much. Bye.